Good evening from the Rooster Inn Observatory. As I try to get everything lined up, please bear with me for a few seconds. Uh, Dwarf is giving me trouble connecting. Okay, I'm gonna have to go grab. I'll be back. Well, good evening from the Rooster Inn Observatory. I'm still trying to line things up. Stellina at least has Saturn in the corner, and let's see if Seestar was able to get it. Yeah, it's certainly overexposed, so that's no good. It has already left the field of view from the vantage point of the Edge HD. But let me show you what I captured just a few minutes ago. Okay, don't want to show me. Okay, it's not opening it. It's showing the D-Bayer patterns. Okay, Saturn looked good a little while ago. By the way, I forgot to introduce to you my assistant Murphy of Murphy's Law fame, which means if anything can go wrong, it will. And so far, it has been touch and go. My latest challenge has been getting the Dwarf up and running. It had refused categorically to connect, but it has finally connected. And I want to see if we can get it in astro mode and get it calibrated. I have the Dwarf mounted in on an equatorial mount. That's not good. It has enough stars to resolve. Oh, good. Now, I'm not expecting much out of Dwarf when it comes to Saturn, but I plan to go through the motions of the go-to part. Yeah, there is Saturn. Let's see if it pulls it in the center. It did. All right. Now, the only thing worthy of observing at this point, Stellina has lost Saturn. It was tracking it. So I'm gonna try to convince it to go back to Saturn, see if we can find it again. Otherwise, it's time for everybody to go to Neptune at this point. Solar system, Neptune, observe. Sky atlas, objects, search. Neptune. Go find it. Where did Dwarf go? All right. I'm going to see if I can fit all four. We're almost there. Okay, both Stellina and Seestar have found Neptune. The tiles are going to prove more important when we start dealing with the deep sky objects. I'm trying to manage as much as possible the big screen. I just removed the second taskbar, and looks like we have a fairly reasonable display at this point. Okay, from left to right, I have Stellina, Seestar, Edge HD, and Dwarf. Let's see if Dwarf wants to go to Neptune as well. At this point, Edge HD is the one with the best chance of seeing it. Again, not much to show in this case, but that is indeed Neptune in fairly wild atmosphere at this point. Jupiter should be high enough to have a go at it. On the front page of the Seestar app, it talks about Jupiter in opposition and recommends seeing it and watching it. Okay. Sky Atlas. And Jupiter. Let's see if the big guy wants to go to Jupiter without giving us much trouble. I am using Starry Night to drive the telescope. And if we do not have instant success, we will resort to plate solving to find Jupiter. Oh, there it is. Okay. I will come back and adjust the... Okay, Stellina has Jupiter. And Seestar has a very overexposed Jupiter. And this is the Edge HD. If anyone has any chance of showing Jupiter properly, it's going to be it. Yep, this is 1/1000th of a second. And we were not too far off. I am centering it so I can reduce the field of view, the capture area, so we can see it. And there are two moons that are barely visible. So here's Jupiter. The great red spot should show up closer to 8 o'clock. But for now, I'm going to do a quick capture of 30 seconds and then process it almost right away just to see what kind of quality it is giving us. And then we're going to go try to play a game with Seestar. Ask it to go to the moon, which it will not find, have it fail, and then see if we can manually slew it all the way to Jupiter, and then see if it will display Jupiter without overexposing it. I have captured 4182 frames, and what I would usually do in this case is open Astrosurface. Uh, and there is Jupiter. And this is the Bayer pattern. We're going to register it. detect the planet, and I'm going to stack only 20%. Even that may not give us good results tonight. Still stacking. And adjust the levels quickly, and then go to the wavelets. This may be the best that we're going to get tonight. So this is Jupiter. You can see in the corner the start of the uh, great red spot. It's down there. And these are two of the moons. So that is not too bad, given that Jupiter is only at 23 degrees altitude at this point. That's too much. Okay, I'm gonna save it, and we'll declare this a partial success tonight with Jupiter. It is still there and drifting on us. We'll come back to Jupiter in a few minutes and take a closer look at the great red spot. In the meantime, we're going to exit the full screen and send the Celestron back to the corner. The one I'm most interested in trying to pursue at this point is the Seestar. I'm going to see if I can convince it to go lunar. Not too good. Jupiter is still fairly overexposed here. And yeah, I have not been able to affect in any way the overexposed nature with Jupiter. Now, Seestar may have take that back, Dwarf may have a fighting chance of displaying Jupiter if we go to much lower gain, IR cut, and exposure. Okay, it's 2 big pixels and not much else. So in this exercise in futility, I try to illustrate that the smaller scopes are not meant for planetary observation. The one that has come probably closest to showing anything is Stellina, and even then Jupiter is obviously very overexposed. The next step before we move on to galaxies is going to be Uranus. We're going to go again to all 4 and then see if we can spend some time with the Celestron with Edge HD, looking at Uranus, and then I'm going to come back to Jupiter before we leave the planets to take another picture of the great red spot. It is creeping towards the center. So we're going to stop Jupiter and go to Uranus. That is 1. The Sky Atlas on Seestar is very nice to use. I'm going to go back to the full field of view and slew to Uranus. And there is Uranus. It's slightly less blue than Neptune and slightly bigger. I'm going to put the crosshair to center it. And then zoom in a lot. Uh-oh. That's not what I meant. This is what I meant. It is just a little bit overexposed. The histogram doesn't show it overexposed, but obviously it is because of all the white in the middle of the blue. And then I try to lower the gain. There we go. Yeah, this seems to be good. I'm gonna grab a minute. We're at 15 frames per second, so that will give us about 900 frames. So enough to stack and see if we can get the semblance of a planet. Forgot to rename the target, so it's still showing it as Jupiter, but we'll rename it as soon as we finish the capture. All right, we have a capture. Let's see if we can process it. I like to use Astrosurface because it gives me all the tools that I want in one place. And it is free. There is my file. It has detected it. And we'll still go with 20%. Obviously, it's not taking much time. The big thing to do here, besides adjusting the levels, is to align RGB. Okay, we're fairly good. And I don't think we need any wavelets here. If anything, some noise pre-filtering. And don't know if we can do much with the wavelets. Really, not much to do. It is a bluish blob, and that's about it. So we can save it. And that is Uranus. All right, let's see if Dwarf wants to attempt to find Uranus. Feature, auto go to. All right, did Seestar find it? Yeah, and it's overexposed. So we have it on Stellina. Fairly good, faithful colors. Very overexposed. On the Seestar, good on the Celestron, and not sure if we have lost the Dwarf. Dwarf does not seem to be happy. I want to take a quick look and see where M34 is at this point. and possibly get started with our deep sky object part of the program. It is high enough. It is at 34 degrees altitude, so it'll be good to get started on it. I may have to make a trip downstairs to see why Dwarf is not happy. In the meantime, Stellina. Seestar. Apparently the new app. Okay, there we go. It is up and running. I'd like to refocus. And then we'll start capturing. I do not believe that M34 is in the catalog, so we'll have to go to it manually. So it is 2 hours 42 minutes. RA 2 hours 42 minutes. The image enhancing on Seestar, it's taking darks. That's what it's doing. So we have RA of 242 and the declination is 42 degrees and 46 minutes. Okay, 242 and 4246. Let's go. I don't see any activity. Okay, it claims it's not connected. That dwarf is not there. Okay, that calls for a... Okay, there is dwarf. And it's a very good signal. Uh-oh. Okay, dwarf is back. Let's see how much we have missed in the meantime. Zero 42. 2. 42. And then 42, 46. All right, there's hope here. Although I do not see any evidence of any stars on it. What? Dwarf is not happy. In the meantime, Stellina and Seestar are happily stacking M34. In my mind, the highlight of the night is going to be the Crab Nebula M1. I'm eager and anxious to compare the Very Large Telescope to the primarily Stellina and Seestar, and I'd like to get the Dwarf working again. I'm going to take a short break from you, ladies and gentlemen. Let me get... Let me take care of Jupiter one last time. I want to grab another picture of the great red spot, and then I'll go downstairs and see what the problem is with the Dwarf. And there is Jupiter. That's a beauty of a nicely polar aligned telescope. I use Sharp Cap Pro to do my polar alignment. It's very, very nice. As long as you can see Polaris from the telescope, it will do beautiful polar alignment without hassle. Single crosshair. Move it up. Center it. I don't know if the sky is calm enough to go take a look at Ganymede, but for now, let's take care of another good picture of Jupiter. I like to adjust the histogram so it is about halfway stretched here. So we can either increase the gain. Yeah, that's about good. There's still bluish sky, if you want to call it that. I'm going to go to 800 by 600. I'm going to go slightly larger capture, 90 seconds. The great red spot is obviously there. 90-second at 90 frames per second. That's going to give us a good 8,000 frames to stack to pick the top. I'll go with top 10% and see how clean we can get Jupiter. Uh, 23 seconds to go. Okay. So we have the Bayer pattern. We're going to register it, detect the planet. It did. And I'm going to go with 10% out of 8,000 frames. So that's still 800 frames. It's going to pick the best 800 frames and stack them. It's going to take just a little while to analyze 8,000 frames and pick the best 800 to stack. Right now we're looking at Jupiter. Looked at Saturn earlier tonight. And then the big prize of the night for me is going to be the Crab Nebula. And then we'll do an easy one, Orion, and then by far my favorite, the Horsehead Nebula, around 11 p.m. Eastern. All right. Stack it. Done stacking, we'll edit. Auto levels. And then wavelets. First thing is to apply the noise pre-filter, and then reduce the strength to about 50%. Apply some low frequency wavelets, and now starts to work. But really it's a matter here of preference. What do you consider good? It's in the eye of the beholder. But the great red spot is very visible at this point. It is right there. And we are seeing a couple of moons. So this is good enough to save at this point. And then before we leave Jupiter completely, I want to see if we can get to its biggest moon. Let me find out which one of those four is Ganymede. Ah, way too crowded. Let me pull a different display and find Ganymede among them. Ganymede is the one farthest out. Okay. So there is Ganymede. Let's see if we can move to the middle, to the center, do that manually. And then zoom in on it. I'd like to adjust exposure. It's just a little bit overexposed. Ah, I don't know that we're going to be able to do much processing with this. It's the atmosphere is wildly playing tricks with it. So we're in with about 3,000, 3,600 frames. Even if I pick 1% of these, I don't know if we'll get much to stack. Okay, files open. Let's try 5%. stack. Done. So this is Ganymede. Don't know that we can do much with it. Want to make sure we have at least the colors aligned. Yeah, there was a touch of correction here. And then I will try to get rid of some of the noise, some minimal low frequency wavelets, and let's see if it's going to allow us to do even one of the high frequency wavelets here. I think that's it. Okay. This is Ganymede. Jupiter's largest moon. So here's Jupiter with its 4 moons. A quick 30-second capture. The Crab Nebula is still at 7 degrees altitude, so it's going to require another at least half hour before we can attempt to image it. Please notice that Stellina and Seestar are displaying the same thing, but in opposite order. Looks like Seestar has more stars to show than Stellina, but it is an interesting cluster. And one novelty that the Seestar engineers added with the latest app is the ability to turn off all the legends around the picture, so we can turn them on and off. One other thing I can demonstrate about the Seestar is the mark. It will identify the object that you're looking at. It says this is indeed M34. And I'm going to take a quick break to go see what the problem is with Dwarf at this point. Be right back. We seem to have gotten Dwarf to work again. So it is stacking the same galaxy. It is way behind, obviously. As I indicated earlier, the big feature tonight is going to be the Crab Nebula M1. Now what I want to do here is attempt to go to M34. Well, M45 obviously is there. And there is M34. We're going to slew and be prepared to do some plate solving. This may be a good opportunity to illustrate plate solving on the big rig, as I call it. I normally go with 8 seconds. If 8 seconds fails, I'll go with 15 seconds. Oh no, plenty of stars for it to succeed with plate solving. And it'll automatically recenter. And once it recenters, it's a matter of deciding what kind of exposure to use. This looks reasonably good. So we're going to go with live stack. I have the option here of subtracting the darks. So subtract dark, and it will automatically use the right darks. And we'll go with live stack. And under live stack, I have the option of enabling recentering whenever it moves by more than 100 pixels. So there is no guiding, but this allows it to recenter whenever the drift is more than 100 pixels. And then it will do plate solving every time and redo it. So here we go, we are stacking happily. I have the ability to adjust the histogram based on either auto color balance based on the color of the star, which I just did. And we can auto stretch if necessary, or manually adjust the black level. There is some nebulosity in it, but for now we're gonna let it stack. Okay, all 4 telescopes are stacking M34. Obviously with very, very different fields of view. Stellina and Seestar have similar field of views. but the other two are dramatically different. Something I should have done a lot earlier, and that is to label the different telescopes, different instruments. And the only one that is not labeled, obviously, is the Edge HD 11-inch. I cannot tell you enough how excited I am at M1. As soon as it reaches 15-degree elevation, we will see if Stellina likes it. Stellina usually does not like to image deep sky objects below 20 degrees altitude. But as soon as Stellina is happy, we're going to go with M1, which will be the highlight of the evening. Needless to say, the C11, the Edge HD-11 will show it much, much larger than the other three. But in my mind, the shootout is going to be between Stellina and Seestar as to which one of them is able to resolve more colors out of the out of M1, out of the Crab Nebula. I will make sure that the light pollution filter is turned on the Seestar so that it will allow as much infrared as possible. The Dwarf is reasonably well focused tonight. Actually, at that, all of them are very well focused. So focus is not going to be an issue when we're dealing with a nebula. For me, this is the first, being able to stream all four instruments at the same time. For whatever reason, Dwarf refused to come up in station mode, which denied me the ability to control it directly via Wi-Fi. and I had to go Bluetooth, and I am too far for Bluetooth to work. Please note and notice that the Dwarf is mounted equatorially. It's on an EQ mount. So the only one, actually both Stellina and Dwarf will not show any field rotation. The Edge HD-11 is mounted on a CGX mount, which is equatorial, so there is no problem there. The only one that is likely to show field rotation is going to be Seestar. It will be more visible with the Crab Nebula than with M34. Let me show you one other fancy feature of Seestar. If I double click on it, it will zoom in. And double click again, it will zoom out. Again, that will come in very, very handy when we're looking at a smaller target. As the night progresses, I want to do Orion just because it is there and it's a beautiful target to image anyway. We don't need to spend much time on Orion. Okay, so we discarded one image. Let's hope it's not discarding many more. Okay, it's stacked. We should be able to see Orion from the very first frame. So as soon as we start stacking, it will be there. So we don't need to spend much time on Orion. But then we'll hop on the Horsehead Nebula, IC434. That one is going to be interesting to do on the Edge HD-11 because the Horsehead will fill up the field of view. And given the nebulosity, it'll be interesting to see how the Seestar will do relative to Stellina. Crab Nebula M1 is at 11 degrees now, 12 degrees above the horizon. And we are at 8:22. So my estimate that we will be imaging the Crab Nebula beginning at 2100 or 9 p.m. is going to be fairly accurate. I want to point to you an interesting phenomenon here. I'm going to start with the Edge HD. I hope you can see the cursor there. Let me verify that the cursor is visible. Yes. That pattern of 7 small stars that appear like a lasso or a circle is repeated exactly here, and it is exactly there. And these are very, very tiny stars, obviously, in terms of magnitude and distance. But those big, bright stars are the essence of the M34 cluster. The power requirements of those four devices are dramatically different. The Edge HD on a CGX mount, sitting in the pod with its own computer, a dew heater around the lens, is powered directly from a mains power, 115 volts, through a UPS. Dwarf is draining the battery even though it is plugged into a USB adapter that provides 3 amps. Don't understand that one. Seestar is plugged directly into mains power, so it'll go on forever. It is at 100%. And Stellina has a 50,000 milliamp hour battery that is driving it, and it should carry it all night. If the dwarf drops below 30% battery, I will go down and switch batteries on it to keep us going. I'm going to go grab a cup of tea. Can I get anything for anybody? Be right back. Don't know what happened to Seestar. I just went out to get a drink. Let's see. We are not connecting via Bluetooth. We are in station mode. Interesting, it jumped onto connecting to Dwarf. No. We are connecting to space. Which should allow us to go back to very strange. The Wi-Fi on the device jumped from the space subnet on which all my telescopes ride and connected to the Dwarf Wi-Fi signal. Very strange. Okay, we're back. We did not lose any stacking. Mr. Johnson, thank you for the kind words. I'm glad you're able to join us and watch tonight. I'm looking forward to the highlight of the evening, which should be starting fairly soon, and that is the Crab Nebula. Pulling off the four instruments at the same time is a nice technical, it was a nice technical challenge to work on. Since we are experimenting here, I'm gonna move on to M1 as soon as I save the images from M34 so we can look at them later. M1 is exactly 15 degrees altitude now, so let us see what the four devices do at that altitude. Okay, let's start with Stellina. Let's take a picture. It saved it in singularity. I'm going to save another picture. And we're gonna do the same with Seestar. Seestar saves it automatically as soon as we stop it. Live stack, we're gonna save it. And then stop the live stack. And finally with Dwarf, when we stop it, it's gonna save it. Now the race begins to go to M1. Okay, Dwarf is already there. I'm gonna go with IR pass on all of them. And I'm going to increase the gain on the Dwarf to 90, so it will be identical to the Seestar. I'm going to start capturing. And there is Seestar. Okay, the filter is on. I don't know what Dwarf is doing there. Uh, there is no green light whatsoever down there, so I don't know what's happening. And now the big rig. Sorry, it's going to take a couple of steps to get to M1 here. Let me search for it and find it quickly. And we will do a quick plate solve on it. And as soon as it's centered, we will start capturing. Looks like we are centered. Let's see if it. Gonna go with 15-second exposures on this one. And let's make sure we have the right. Okay. Obviously, the big rig is higher maintenance. There is the Crab Nebula smack in the center. And we are stacking. Just gonna adjust the white uh, balance. Doesn't want to do it. Okay. We'll send it back to the corner and we'll come and visit with it momentarily. So here we are. I have the light pollution filter on, so it is IR pass. I have infrared pass on the Dwarf, and we'll worry about filtering here later on as soon as it. Uh-oh, it is rejecting frames. That's not good. That's more like it. Okay, here we are. The Crab Nebula as seen by Stellina, Seestar, Edge HD-11, and Dwarf 2. Stellina recommends half an hour of capture on this one. I think I'd like to give it a full hour and see what we get as a result. I can already see that Seestar has some greenish tones inside the Crab Nebula comparable to what the Edge HD is getting. Even though I have turned on dark subtraction on the Edge HD, I'm still getting some leakage from the sensor on the left side of the screen. I'm not sure where the dwarf is picking up green, but I have taken care of it by zooming in a little bit. Putting 4 telescopes side by side, and all of them have their own little lights that are on. One of them may be shining straight into the lens of the dwarf. Quick reminder for those who joined us recently, a dwarf is on an equatorial mount. I use its own tripod, the little tiny tripod that came with the dwarf. I can tilt the head, and by spreading the legs flat, uh, it gives me a extremely well-aligned equatorial mount. I have no problem whatsoever with it. Okay, Edge HD is rejecting frames again. It dropped the last 10 frames. Uh, I'm gonna try to go with 30-second exposure. See if that makes any difference. The big question to ask now is, are we dealing with clouds in the area? Is anybody stacking? Nope. Seestar has stacked one dwarf. Stand by. Let's see if I have to move the clouds out of the way. Okay, two things have happened. Stellina has stopped stacking, and Edge HD has stopped stacking. The only two telescopes still stacking are Seestar and Dwarf. I don't know if we had a cloud that went through. I'm going to restart Stellina. I'm not giving up on that. This is the second time I try to compare Stellina and Seestar on the Crab Nebula. Let's go again. I want to do the same with Big Rig, clear. And let's see if it will resume stacking. It is stacking again. There is one thing I want to modify, and that is the dark, the automatic subtraction of darks. And I want to see if I can adjust the histogram. And we have guiding enabled. So with a bit of luck, we should be back in business on this one. I'll keep an eye on it. Stellina has resumed stacking. Seestar is still stacking, and so is Dwarf. Athol, I understand that many people who ordered their Seestar late in the summer are getting them now. So depending when you ordered it, there is a good chance you'll get it before Christmas. So I pushed to 30-second subs on the Edge HD just to ensure that it has enough stars that are bright for stacking purposes. I do like the fidelity of the Crab Nebula on Seestar so far. It has quite a bit of structure in it. Right now, more than any of the other three displays. The first week of March, probably around March 8, March 9, are supposed to be the ideal dates for a Messier marathon in 2024. For those not familiar with the Messier marathon, that's attempting to image all 110 objects in the Messier catalog in one night. So you start right after sunset with the galaxy that is about to set. And then you travel the sky from west to east as the night progresses and try to catch the last two or three before sunrise. The further north you are in latitude, the less likely you are to get all 110. I am at latitude 43, so the best I can do is going to be about 105 of the 110. I plan to go for it. And the big uncertainty for me is which device to use. Okay, Edge HD has stopped stacking again. It's dropping packets. It has rejected the last three frames. We may have to give up on the big rig for this activity. So as I was saying for the Messier Marathon, with about 10 hours of usable night. It doesn't want to stack. Okay. I don't know if going the full minute is going to make any difference here. So we're looking at about 10 galaxies per hour, so we have about 5 or 6 minutes per galaxy. And the big characteristic that I'm looking for is the speed of slewing and plate solving. Right now, Dwarf is superior to any of the other devices. Seestar, on the other hand, is likely to give us better quality of whatever it is that we are stacking. I have restarted the stack on the big telescope, going with 60-second frames right now, which is giving me almost elongated stars. But if it fails to stack again, we will retire the big rig for now. I don't know if adjusting the exposure is going to give us a slightly darker sky on Seestar, so it'll be comparable to what Stellina is showing. Lost quite a bit of the Crab Nebula. One of the exercises that I plan to do in the near future, while M33 is still with us, the Triangulum Nebula, is to image it with Seestar with the filter turned on. I'd like to allow as much infrared as possible to see if I can observe, if I can image the nebulosity inside M33. I'll probably come back to the Crab Nebula to M1 and image it without the filter. The filter is turned on right now. That's why it's green. Just so I can compare side by side. Unfortunately, the amp glow is showing on the left side of the Edge HD screen. Up here, the ASI183 camera from ZWO is known for amp glow. That is a leaky sensor, basically. The current that's flowing onto the chip shows up like that. Even though I took darks that are supposed to take care of it, they are not. I re-engage the darks to make sure we have the right ones and see if I can ameliorate that. The Dwarf has stacked 148 frames so far. Seestar 108, that's 18 minutes times 6 frames per minute. And Stellina is only now catching up. It's halfway at just 10 minutes, which is 60 frames. It will catch up with the Seestar. What I just did on the Edge HD, on the sharp cap, is I asked it to correct the histogram to make the stars white. It has two ways of histogram correction. One that makes the whole thing as close to gray as possible when it adds up, versus looking at the colors of the stars only. And this is the difference between the two. I don't think the sky is that blue right now, so I'm going to go more so with this one. I will refrain from suggesting at this point that one is better than the other. I do want to stack an hour worth of images before I do a comparison of any value. Not sure why Stellina has more of a red tilt. Uh, it's supposed to have its own uh, city light pollution filter. It's going to be interesting to look at the analysis of the two structures. A good comparison, which I plan to do, is going to be the Veil Nebula, given that it has a range of colors in it, from blue to green to red, and see how Stellina compares to Seestar. I tried to get my PhD 2 uh, to do the guiding on the large rig, the big rig, but for some reason the guide camera did not want to work. Did I mention that my co-pilot for the night is a guy by the name Murphy from Murphy's Law fame? So if anything can go wrong, it will, and it did. But fingers crossed, things appear to be working right now, and we're going to leave them alone, let them work. Stellina is catching up to Seestar in terms of number of frames stacked. And Big Rig is still stacking, so I'm happy with that part. I'm gonna try the auto stretch on it one more time. Mr. Happy, I am happy that you're enjoying the comparison. I'm still learning as much as I can about the capabilities and limitations of each device. And if I can share that knowledge with you guys, that's what I'd like to do. None of this is rehearsed, it's all live and real time, and I'm not afraid to fail. And we have had a fair share of that tonight. Yeah, I bought mine from High Point Scientific. I ordered it on 17 April and it arrived on the 2nd of October, so it was 5.5 months, which is about what they had promised us. Now that they are making them, it should be a lot faster. If you have not seen my tutorial on how to display your Seestar and Dwarf onto a laptop, please take a peek at it. That allows me to have 4 devices displayed at the same time using putting the devices in debug mode and then using a screen copy with the serial number of each device. This way I can open all of them. I'm going to pull one more display for the benefit of the technical folks here, and that is the task manager. Well, there's not much to show. Bear with me for a moment. Right now, CPU is only 24%, so we're barely using a quarter of the CPU. Memory, I'm only using about 8 gigabytes out of 24. No disk usage whatsoever. Ethernet, obviously. And the GPU, only one of them is doing any work. So even with the 4 displays, we're barely scratching the surface on what is a Dell Vostro laptop. It's just a regular laptop. Okay. I have my display on a 42-inch screen so I can look closely at trying to resolve the differences between Seestar and Stellina. The color differences are obvious, but the Stellina display is a lot sharper. There's a lot more detail in the nebula itself. I don't know if you can see it closely, but at the very heart of the nebula, the detail here on Stellina is much more vivid than it is on the Seestar. I would have expected a lot more detail with an 11-inch scope, and let's see if we can get it. Almost. But this is the detail that I'm talking about, the ridge inside the heart of the nebula. On the 11-inch, I can see multiple tiny stars, 1, 2, 3, 4, and then another few here surrounding that center. I can see one, the brightest one on Seestar, and another tiny one here, but that's about it. And remembering that Stellina's display is upside down, Stellina is showing me those tiny stars. Here they are. Yes, Stellina is certainly showing more detail, a lot more detail than Seestar. I don't know if we can ever resolve the color issue as to which one of them is more faithful reproduction of color. Looking at what the 11-inch scope is showing suggests that there is greenish stuff in the nebula that Stellina is missing completely. Now, as a reminder, Stellina has an 85 millimeter aperture. Dwarf is a 50 millimeter aperture, so we're talking about 3 inches versus 2 inches. 3 square is 9, 2 square is 4. So Stellina's light capturing ability is at least twice that of Dwarf, sorry, of Seestar, and 9 times that of Dwarf. I'm glad that the 11-inch has finally agreed to behave and is stacking, because there's going to be something very nice about that image that the other two cannot show. Yeah, I'm going to have to stick to adjusting the histogram manually. And the amp glow is a well-known problem with that sensor. However, I do want that 21 megapixel resolution that it gives for planetary imaging, which is the primary use of that scope. We are halfway into this exercise. We're at 29 minutes stacked on Seestar, 240 frames on Dwarf. That is 40 minutes stacked on Dwarf. And I think it's 20 minutes on the 11-inch. There is no doubt now that Stellina is showing a lot more complexity in the detail. I want to point to you something that was not visible a few minutes earlier, and that is this little uh, feature which I could not see a few minutes ago, and it is definitely not as visible here on the Seestar. Now, since we cannot be everywhere at the same time, Comet 12P Pons Brooks is not too far from M1 right now. except that it is setting. The reason I mention it is on April 8, 2024, on the big solar eclipse, we will have totality up here in upstate New York, and I plan to have multiple telescopes to image the clouds. There is a 60% chance of clouds on that day. With the big, however, if the sky is clear, comet 12P Pons Brooks is going to be near the sun and the moon when we have totality. The sky is supposed to turn dark, dark enough that we'll be able to see the comet. Another interesting phenomenon that will happen is that almost all of the planets will be lined up. We're talking about Saturn, Mars, Neptune, and then the two inner planets, as well as Jupiter, will all be lined up with the sun and the moon. And given that it's going to be dark, I'm going to have a regular telescope also try to image these. Color on Edge and Seestar and Dwarf are similar, but Stellina is reddish. Yeah, I don't know if it's going to be a popularity vote here, but there is agreement among three of the telescopes that there has to be other than red in that nebula. If I can find it with my binoculars, I'll tell you what colors it has. For those who have the Seestar or plan to get the Seestar, let me show you a couple of features in the new app. This one is a biggie. I asked for it, and they delivered the ability to toggle on and off all the controls on the edges of the frame. And in solar mode, it is able to find the sun. Andrew, I don't know the answer. Don't know why Stellina is filtering out the higher frequencies, the higher wavelengths. You guys are putting the burden on me to find the target where we know what the color is and see what Stellina does with it. I'm going to attempt now to see what NASA pictures look like for M1. With the concern is if they are imaging it with a narrowband, then they might be recreating colors that bear no resemblance to the reality of what the nebula itself looks like. I'm trying to manipulate the colors on the 11 on the Edge HD, and I'm unable to come up with any combination that puts red in the center of the nebula. On both Stellina, actually on all three, Stellina, Dwarf, and Seestar, I'm using light pollution filters and letting in everything else. I did not put any external filters. I'm using the internal filters that came with the devices. Good evening, Lauren. Yeah, lots of green NASA pictures. So the burden is on us collectively to find another target that we can do on another session that has a variety of colors in it and see if Stellina is indeed color blind. I just enlarged Stellina with my two fingers. Seestar is not letting me enlarge the display with two fingers. Okay, it just did. But that is the extent of it. I am pleased to note that Seestar is starting to show the fine structure that Stellina showed several minutes earlier. And it is worth noting, if you look carefully at the Edge HD, you will see 1, 2, 3, 4, 5 stars in a row, whereas on Seestar, those stars appear as a wedge or a ridge. And almost the same with Stellina, although Stellina shows a couple of stars, the rest of them appear like a wedge. We are Bortle 4 here. Yeah, Dwarf is not doing too well. I did a comparison between a Dwarf 2, between a Bortle 2 and a Bortle 5, Bortle 2 and Bortle 4 using Dwarf, and the results were eye-opening. I'm going to put the link to the Bortle comparison if anybody wants to take a quick look at it. I have promised to compare Bortle 8, 7, 6, 5, and 4. And I can do that by driving only 10 miles, actually. We live 10 miles from the city of Syracuse, and Syracuse downtown is Bortle 8, 9. Fortunately, there's a mountain shielding us from their light, but I should be able to drive. I don't know that I will be using Dwarf for that experiment. It will most likely be Seestar. Seestar is a lot more portable than Stellina, as in 20 pounds more portable. Dwarf 2 has had problems passing colors through. I do have IR pass, and still is not showing much color there. This is Dwarf 2 at full field of view, all 3 arc degrees. So the native images, if you want to look at them per se, that'll be Stellina, and that'll be Seestar, and that is Dwarf, and that is Edge HD. These are the native unstretched images of the Crab Nebula. Stellina caught up with Seestar. Stellina is almost 40, it is at 42 minutes stacked now. Seestar is 42:40. Dwarf is approaching an hour. It will get to the hour very soon. As soon as it gets to an hour, I'm going to stop it. I'd like to stop each of them at exactly 1 hour of stacked images so I can have a fair comparison. I'm going to take a quick look at how much Edge HD has stacked. It is at 44 minutes also. So we're going to be reaching the hour fairly soon on all of them. Lauren, if you're asking about binning, this is 2x2 on Dwarf. But I am very happy with the absence, the lack of any field rotation on any of them. Let me try it. Uh, it's bringing out red everywhere. I will take the eventual image and post-process it to see what I can get out of it. But I will be stopping the Seestar in another 10, 20 seconds, maybe. It will reach 360 stacked. And then we will send it looking at Orion. Because that's going to be my next stop for all of them. All right. Dwarf has accomplished its mission. We're back to live. And it should be able to find Orion without any problem. Under 20 seconds. It found it in under 20 seconds. IR pass, gain 80, and 10 seconds. Let's go. Yes, Lauren, the new app supports 1x1, and I'm looking forward to testing it. We're going to have to rerun all those tests with the new app. For some reason, we lost the red immediately from Orion as soon as it started stacking. We're at 48 minutes on the Edge HD, 46 minutes and 47 minutes. It is on auto white balance. I don't know if I can still change it. No, it doesn't let me. It is IR pass. Lauren, in what area of the country do you live? Oh, I envy you big time. So are you Bortle 2? At least you're not too far from Bortle 2. One of my favorite marathons was Run Crazy Horse in South Dakota. The beauty is just unbelievable, that part of the country. And considering dark skies pretty much everywhere, Bortle 4, you cannot be too far from a Bortle 2 somewhere. Now, it is worth noting that the density of stars on Stellina is a lot higher than that of Seestar. David, what got me into this hobby was my grandson who visited from the big city and saw stars in our skies that he had not seen before and asked if he can get a telescope. So I got him a telescope. Actually, I got me a telescope that I sent him, and then I got another telescope, and then another telescope, and they kept getting bigger. And now I find myself with a whole collection of them and enjoying every minute of it. Edge HD is approaching 1 hour. It is at 57, I believe. Yes, 57 minutes. Not much more detail here than I'm getting with the smaller telescopes, but the color differences are obvious. This one is showing reddish only at the edge and some red here. The rest of it is whitish greenish. 58 minutes. Yeah, Canada has no shortage of Bortle 1 skies. I wish I can find out what magnitude those stars that Stellina is seeing right now. Uh, there are some incredibly tiny dots all over the place that Seestar is not picking up. All right, we should be uh, approaching the end of the road on Edge HD. So I'm gonna save it, and then we'll send it to get started on Orion. Let me see one thing first. 10 o'clock, save it. And stop the live stack. I want to see where Jupiter is, because the great red spot should be very visible now. Okay, I'm going to take a quick peek at Jupiter with the big rig. I use Starry Night to drive the telescope through the ASCOM Celestron driver. And let's see how good it is tonight. Not bad. Let's get it smack in the middle. Not bad at all. And I'm going to change the area here. Let me verify the histogram. It is excellent. I want to grab a minute. It's capturing them at 90 frames per second. And then I'll stack them quickly just to illustrate the beauty and the ease of using Astrosurface. Right now, the seeing is very poor in my area. On a scale of 1 to 5, right now we are at 2. All right, it's done capturing. Let me show you quickly how fast I can get that file stacked. There it is. We'll do the debayering, register, tell it it's a planet, and then I'm going to go with 10% of the frames to stack them. I have 5,000 frames, so we're stacking about 500. Done. Okay. And stack it. It's done. Edit. It's a matter of do we want to make it a bit brighter? Yes. And wavelets. I'm going to reset. Start with the noise pre-filter. Add some low frequency wavelets. Reduce the strength to about 50%. And this is where magic happens. With every click, you get more detail. And this is where it becomes a matter of taste. I think this is enough. The great red spot is out here, but this is a reasonably good picture of Jupiter, considering the poor seeing that we have here. I'm going to save it as a JPEG, and let me open it just so we can take a nice look at it. That's what we ended up with. Not bad. Yes, it does deconvolution, which I did not do. All right, it is time to send the big guy to M42. Okay, it is slightly out, so let me do a plate solve on it. That is what I call lazy imaging. I can plate solve it and it will recenter, and then we start capturing and stacking. That's what it considers the center of Orion. Okay, let me go with 30 seconds and adjust the darks here. As soon as it finishes the first one, we will start stacking. Okay, don't know why it is not stacking. Okay, we have a problem. There it is, but it's refusing to stack it. There's one thing I want to point out to you, and that is the 4 stars at the heart of Orion. Not too many images or stacks end up resolving those 4 stars. But I look at these as a critical component of the display of Orion. Sharp cap doesn't want to work. All right. We exit and we re-enter. Okay, this is beautiful. Okay, it's sounding more and more like it's time to retire this one. Okay, we have the full hour on Seestar and Stellina. Okay, we're going to send them both to M42. This little green circle here suggests that we should uh, allow infrared through, which we will do momentarily. And then Stellina and observe. The new app on the Seestar seems to be hesitates when it gets to the middle. Okay, there we go. It has started. Filter is on. We're still good focus-wise. We're going to start capturing. All right, let's see what we can do about this guy. Focuser is on. Let's drop exposure. I'm going to stop stacking. Thank you. There's too much scintillation there. I'm trying to find a couple of clean stars to refocus. Okay, get me out of here. Okay. Okay, we're done with the refocus. Let's see if it makes a difference. Okay, I will leave it up to you guys to decide which one looks nicer, Stellina or Seestar. Both have extremely sharp pictures. So I refocused the Celestron Edge HD. Again, that's a beautiful feature of sharp cap. Dwarf 2 is equatorially mounted. It is polar aligned. Yes, my research suggests that the vertical orientation of Seestar helps it cope better with field rotation. Yeah, I mean, I don't know how much better you can get with post-processing on these images. Both Stellina and Seestar are absolutely gorgeous. Now, if you look closely enough, Seestar is showing the sky as dark blue. Uh, Whereas Stellina, I don't know why it has all that reddish around it. But other than that, it's showing the sky as black. I skipped Orion on the Edge HD and went to the main course, which is the Horsehead Nebula. I don't know how well it's gonna do. Okay, I think they have all done justice to Orion. So I'm gonna have them follow the big guy and start with the Horsehead. That's gonna be a beautiful comparison. Stellina complained visibility poor because it's at 19 degrees above horizon. It would like it to be 20. All right. Yeah, the specifications of Vespera are identical to those of the Seestar, the technical specs. I'm looking forward to what Vespera Pro will bring because it's a much larger sensor and it's a square field of view as opposed to rectangular. When people image the Horsehead Nebula, they almost always include the Flame Nebula with it. Uh, Tonight, the only scope that will have the Flame Nebula in it is going to be Dwarf because of the field of view. Uh, I intentionally do not want to include Flame because it's a lot brighter than the Horsehead. I just want to see what they can do with the Horsehead alone. Yeah, David, when I ordered the Seestar, it was a question of bet on the jockey, not on the horse. I was at the Northeast Astronomy Forum down at Rockland Community College, and that's when they unveiled the Seestar on April 14, 15. As soon as I got home, I ordered it, sight unseen, betting on the jockey, so to speak, because all my cameras in the past had been from ZWO. They know how to build good astronomy cameras, so I assumed they can build a good scope and never regretted it. Well, thanks for the compliment. Well, I wanted to see what a big celestron can do. It is not intended for deep sky objects. Certainly not with an ASI-183 camera, but uh, I looked forward to the challenge of having all four at the same time. I'm starting to see horse heads in both Stellina and Seestar, but it's gonna be a while. It's gonna be a while before we stack enough to see a difference. And we are far from done with the comparisons. As soon as Dwarf comes out with the 1 × 1 binning, it's going to be all over again comparing everything. Uh, I just need to line up the proper targets, and that's what I'm experimenting with. Unfortunately, I cannot see either M13 or M15. I'd like a very dense cluster. I also want to see the Stevens triplet, the M65, M66. They will be in the same field of view on all three of them. We did M81 and M82 as well. Uh, that is a mystery as to how they can afford to sell it for that price. Now, remember, the tripod on the Seestar is a decent tripod. Plus, they have a good camera in it. They have the motors. Somebody complained that the gears inside it are plastic. It's for $400. Give me a break. They work fairly well. Now I need to find a way to turn off this error message which says enhancement is stopped. Anytime it sees one frame that's bad, it displays the big error message, which will ruin any time lapse that we might be getting out of the entire capture. Yeah, focusing the SCT had been the bane of my existence. Uh, When I moved from an 8-inch to an 11-inch, I did not realize how much heavier the mirror is, so that the focuser that pushes the mirror in and out was also moving the target sideways, so I could never focus properly. Uh, and then I decided that it's better to move the camera in and out instead of moving the mirror in and out. So I fabricated a, a system to do that, and it seems to be working better now. I did M51 with Dwarf. Actually, that's what I imaged both in Bortle 2 and Bortle 4. That comparison was M51. Two things with the Seestar that blew me away from day one. The autofocus on DSO is absolutely outstanding. And the other thing is the darks. It takes darks automatically at the beginning of every session. They call it enhancement, so be it. But the filter wheel, you forgot to mention a filter wheel there. You did include the filters in the price. But the filter wheel automatically switches to dark. Taking dark with the Seestar is a lot easier than with the Dwarf. Dwarf, you put it in the box, you put the box in a dark place, and then you take them. I got a laugh out of the guy who found a dark place to take the darks with the Dwarf. After putting it in the bag, he put it in the oven. His wife came from work and turned the oven on to prepare dinner, not realizing that there was a dwarf melting in there. By the time it got to 300, it was a total loss. Yeah, now my mirror is with the Edge HD. I have it locked, so the mirror does not move anymore. And I plan to do the smaller targets. I did the Bubble Nebula, but I'll have to revisit it. And I will be doing Ring Nebula and the Little Dumbbell. Right now, all four telescopes have almost identical orientation for the head. Stellina and Edge are identical. Seestar is rotated counterclockwise by a little bit, and looks like Dwarf is identical to the other two, I should say. Oh, not that far. Okay, that's more like it. Yeah, the Flame Nebula deserves its own separate comparison among all three or all four instruments. The chess player in me likes to see the Horsehead Nebula. We have quite a bit of time to stay on it. Right now it is only 22 degrees altitude and 116 degrees azimuth, so it's 11 p.m. now. We can easily stay another couple hours on it without any problem. My rule of thumb at this point is to check every 15 minutes by using the slider on the YouTube player and compare at 15-minute intervals. And as long as there is still progress, I'm just going to keep stacking. The only thing I need to double check is that we are good at least for another couple hours with humidity. By the time we get to, we have clouds moving in anyway, so we have at most 2 hours before the clouds move in. And usually that's when I second guess myself as to whether I have turned on the dew heaters on all of the machines. Stellina is automatic. Seestar, I'm pretty sure I turned it on. Yep, it is on. And Dwarf. It is, It is on. Okay. Yes, it does. I did that with the Dwarf. Uh, let's see if it is. What is it in the sky now? Yeah, right now it is much too close to the sun. It is below the horizon and rises at 3 a.m. with Venus side by side. Yeah, it's going to be a few weeks before Mercurian's chain M86 and company become doable. Lauren, for the Celestron, I have a separate dew heater that is wrapped around the lens, and I always turn it on. I have a battle rhythm for that machine. I open the pod, I turn off the security camera that will detect any motion inside, I disable the alarm, uh, and then I turn on the telescope, turn on the dew heater, and then remove the scope cover. And then I reverse the process when it's time to turn it off. Looking at Seestar and Stellina side by side right now, uh, Stellina's picture appears a bit harsher than Seestar. Seestar appears just a touch more refined. David, as you keep adding to the list of what the Seestar has, let's not forget the dew heater in there, the automatic focuser. I mean, the motor alone to move the focus in and out, and then the algorithms running on it, the processor. There is a lot more than $400 or $500 in hardware inside that box, let alone all the software, both the app and the firmware. Now, speaking of hardware, one advantage that the Dwarf has over all of them is the double camera. Especially during daytime, I know what I'm looking at, and then I can go to the telephoto lens and I'm right there, whether it's finding the sun or the moon during daytime. Maybe time to double click on the horse. Running Man Nebula is again a target that I have in mind to try to put them all to image it. Yes, I did. All four machines, actually, the big rig is outside all the time, but the other three machines, I took them out 2 hours before I started the session. So they were outside a full 2 hours before we went live. The Dwarf gave me trouble because for whatever reason, it did not boot up in station mode the way it always does. And then I was too far for Bluetooth to reach. So I had to go down and connect to it and then go back up. I have not tried imaging the Milky Way with the Dwarf. I'll give it a try and let you know. We're running out of Milky Way, so don't have too much time left. I'll try it at the next opportunity. Again, it's evident that Stellina is seeing a lot more stars at a much higher magnitude than Seestar is. If you look right above, actually in front of the horse, which is above in this case, there are two stars that are very clear in the case of the Seestar, but there are tiny stars next to them here in the Dwarf. So this star is not visible on Seestar, neither is the tiny one next to the big one. And I guess that's what the difference between a 3-inch aperture and a 2-inch aperture. Now this is interesting. If you look in front of the nose of the horse, on the edge, you can count 5 stars plus one on the nose itself. On Stellina, you can count 3 stars and nothing on the nose. And on the Dwarf, there are only 2 stars and nothing. Sorry, on the Seestar, 2 stars and nothing on the nose. This is the cluster that I'm talking about right here. 1, 2, 3, 4, 5, and then 1 on the nose. In this case, only 3. And in this case, only 2. David, if you mean by sharp focus, yeah, it has been, Stellina has always been very, very good on focusing. The focus, the autofocus on Stellina takes longer than either Seestar or Dwarf. Dwarf has the fastest focus. Stellina takes its time. Looking at the pictures on Seestar and Stellina, they look like a Bortle 4 versus a Bortle 2. That will be an interesting computation to do, interesting analysis to see aperture versus Bortle. Does doubling the aperture give results equivalent to cutting Bortle by 2? In this new world of artificial intelligence, one application that I can think of is an AI that will tell you which telescope to use based on the target. Because certainly each of them has its strengths and weaknesses. There are times where I'd never reach for anything other than the dwarf, and other times where the dwarf is not going to do it. Let's zoom into the dwarf's nose. Just one fuzzy star. That's something else about dwarf, which we don't discuss much. Uh, the stars are not round. I've heard of pinched optics repeatedly, and I've heard of Dwarf Lab replacing telescopes for people who sent pictures that show the stars like this. But from day one, I've never had round stars, and I'm not complaining. Those of you who own a Seestar, I don't know if you have noticed that the bright stars have spikes on them. The I don't know if this is Alnitak or what star this is. I can easily look it up, but it has spikes. Yeah, this is Alnitak. Yep, that bright star. It is outside the field of view on Stellina. It is right there with spikes on it. Another very obvious difference is on the ear of the horse. Uh, Edge shows 2 stars, Stellina shows 1, and Seestar shows none. I mean, this is a fairly bright star, which doesn't appear here at all. It does appear there. When I'm done with this exercise, I am very tempted to run all 4 of the pictures through StarNet to remove all the stars and see what the horse does with the nebulosity. David, yeah, either internal reflections or if the tube holding the lens to the sensor is not perfectly round, then it will generate spikes. I don't mind them, actually. They're okay. The James Webb Space Telescope has spikes. My next project, just for the fun of it, is to run a side-by-side comparison of Seestar and James Webb Space Telescope. I did that comparing Stellina to Webb last year. Take pictures of the same targets and then put them side by side for the fun of it. It is surprising that something like the pillars of creation, uh, Stellina did a good job. Uh, David, yes, and this is where I'm wondering if aperture and Bortle uh, are a trade-off. I can only imagine what the sky will look like on Stellina, let alone on Edge, if they were in a Bortle 2 sky or Bortle 1. And with that in mind, imagine how thick the dust is that shapes the horse. That even on the Edge HD, we're barely able to see 3 stars on the head of the horse itself. So that light is not going through it. It's very, very solid, dark stuff, and cannot see any on either Seestar or Stellina. I just noticed that Seestar is starting to show some detail on the back of the neck of the horse that neither of the other 2 scopes is showing. Let me point the cursor to it right here, this area. Now, in addition to the hardware that we are using, don't forget the software. in this case, 4 different pieces of software written by 4 different groups of researchers. The whole concept of stacking and stretching is a personal preference, and we have 4 different ways of doing it on this screen. Yeah, it is starting to show this reddish area within the black. That was easy. The only one of the 4 that's not no longer showing any progress is the big rig, the 11-inch scope. I would have thought that it will keep showing progress. Yes, I'm using the Android app. I tried stretching, if you mean the histogram. I'm glad you joined us. Okay, I'm looking at a stellarium zoomed in picture of the Horsehead, and it does show reddish around down the neck. And right now, the only one of the four that's showing that reddishness is Seestar. This reddish here. Uh, I do not see it on Stellina. Uh, I do not see it on the Edge HD, and certainly not on the Dwarf. Let me take a look here. Yeah, there is nothing. It's not there. It's not there. So this may be a biggie for Seestar. And there is another detail that's starting to appear also, and that is the mouth. Uh, the gap in here, which is not visible there yet. So we may be seeing distinctly superior performance on the Seestar than Stellina on this one. Not sure with sharp cap. Uh, we have stacked 114 frames. I'm going to use the slider and go back 15 minutes and see if there is any difference. Peter, right now I'm using the machines as they came. Have not added any external filters to any of them yet. My rule of thumb had been use them as is the first year, and then identify capabilities and potential, and then decide what to get. You're looking at 15-minute. The edge has not changed at all in the past 15 minutes. The other three have. Right now, I am most interested in seeing how much better the Seestar can get. I'll appreciate it if you, ladies and gentlemen, propose other targets for future comparisons. Where the Rooster Inn Observatory is located at the edge of a mountain, I have a clear view from the east all the way from north to south. And then I lose pretty much everything to the west. Just a minor mountain. That mountain has the benefit of blocking all the light pollution from Syracuse, though, so I don't mind it too much. The Seestar is zoomed in. I double clicked on it. This is the unzoomed. Everybody is unzoomed right now. Yeah, that's what I meant by the algorithms that they are using. There are definitely four different algorithms altogether here. Peter, if we zoom in on the Dwarf 2, on the horse, we will lose the Flame Nebula, and David will not be happy. He likes the Flame Nebula. Let me zoom in for just 1 minute. Still not much to see. Okay, this was an unexpected disappointment that the 11-inch will perform worse than the 2-inch aperture on this target. IR pass on all of them, yes. Okay, now we have both the horse and the flame and zoomed in. I know that both Stellina and Seestar have built-in filters for satellite pollution. I don't know if Dwarf has one or not. And independently, they all have infrared filters that you can turn on or off. Since the Edge HD was not doing anything useful anymore and the moon is just coming up, I thought we'll look at some craters. As soon as it clears the trees, it is at 2 degrees up now. Oh, we can already see trailers. Does anybody know offhand if we can turn off those error messages from Seestar? Uh, David, do you have any globular cluster in mind? Let me see what's available. Pick your favorite. We have M50, M44, M67, M48, 46, 47. They are all going to be possibilities. Which one do you want? The Dwarf has reached 1 hour of stacked images. It looks reasonably nice. The Seestar right now is winning it. I'm going to give it the full hour. I need to turn off those error messages. Bear with me for a second. I want to see if we have the option to turn off those error messages. Doesn't look like it. I'm looking to see if either M5 or M13 are doable tonight. Nope, M5 is very close to the sun. That's going to have to be a few weeks. M13 is a possibility. By the way, it's almost tomorrow. Well, happy Monday, everybody. No, M13 is not gonna be up till 6 a.m. So that's a no-go. Looks like we have a problem called clouds. I am afraid nature is putting an early end to our evening. There is a large band of clouds that has all but blocked all the stars. Yeah, Dwarf has stopped stacking. Seestar is complaining loud and is not stacking. Stellina does attempt to auto-orient. The sensor does rotate, although you have the option of rotating it manually when you're picking the target. Yeah, now none of the telescopes is stacking anymore. The only reason I'm able to see the moon on the big scope is that there is a very thin area without clouds yet, but the clouds are moving on us from the west. So they have taken out pretty much the entirety of the sky except for a thin layer. So I'm going to wish you all a happy Monday, and I'll be back for more comparisons when we get clear skies again. So for now, so long from the Rooster Inn.